Now, a practice problem for you. If an electron beam in a TV picture tube carries 10 power 13 electrons per second and passing through plates maintained at a potential difference of 30 kV, 30 kV, calculate the power in the beam. So this problem is same as the previous one. It deals with the power, where power is equal to voltage into current. In the previous case, we were given with the value of power and an indirect data was given to find out the current, and voltage was an unknown variable in the previous problem. But whereas now, voltage is given, indirect data for current is given, that is a number of electrons per second value has been given, and voltage is given, So we need to find out the power of the electron beam. So you have to proceed in the same way using the same mathematical relations as we have seen in the previous example. Since this is a practice problem, I am not going to solve the problem, and the final answer is going to be, after you solve, is 48 milliwatts is the power of the electron beam, what you get after solving it correctly. And then we will discuss an application of the theory we have discussed so far. So far we have been studying about current, voltage, power, energy, mathematical relations associated, and how to find out these values of current and voltage in different situations. We have established our knowledge well by doing a number of examples so far, and practice questions also have been given so far. We have dealt with a number of problems. So I would like to discuss one practical application of this theory, the things which we have discussed so far. So that application is nothing but the electricity bills. The electricity bills concept. So the electricity bills are actually based upon the power consumption or the energy consumption. So we consume energy and it is measured in terms of kilowatt hours. So this is the unit of energy used by the power utilities to determine our energy consumption and subsequently the billing. So our billing, electricity bill, is based upon our kilowatt hour consumption. We know that power, what do you mean by power? Power is rate of doing work or rate of flow of energy. So when you call power, it is energy by time. Energy is the total work done, or no, it is total work done in a given time. So P into T gives you the energy. So units of energy would be units of power multiplied by units of time. So we are taking as a standard a multiple unit of power, that is kilowatt, and for time as hour, as the unit of energy in commercial billing. This kilowatt hour is otherwise termed as 1 unit of energy. 1 unit of energy. 1 kilowatt hour is known as 1 unit of energy. If you call 4 units, it means 4 kilowatt hour. If you call 10 units, it is 10 kilowatt hour of energy. Apart from this, this billing or this aspect of billing, electricity bills. So our energy consumption practically is not only dependent on this kilowatt hour or units of energy consumed, but also some other factors actually affect the price of energy or the electricity bill. The other factors are power factor of our load of the consumer, and the maximum demand or the maximum load that is connected, or maximum load that was occurring in a given period of time in that month, maximum load that has been connected to the power line by the consumer in that period of time, say 1 month. So that maximum demand. So there are such kind of factors, other factors apart from the kilowatt hour consumption, which affect the energy consumption, which affect the electricity bill. So however, we are going to not discuss about this cos phi, the power factor and maximum demand. And however, as we progress into the course, we will be seeing what does this cos phi or power factor which I was talking about means, and what is the maximum demand, more illustrative and more deep understanding of these terminology. For simplicity's sake, I will be talking only with regards to kilowatt hour as far as our discussion on electricity bills is concerned. So let's solve an example regarding how the utility makes an energy billing, say for a consumer. He has a house, and in the month of January, okay, Raman in the month of January, he consumed 700 kilowatt hours of energy. Okay, Mr. Raman in the month of January consumed 700 kilowatt hour of energy, which is nothing but 700 units of energy. So we have to determine his energy bill or electricity bill. So what is the electricity bill? So there is something called as a tariff. It means the cost of energy which the consumer pays for what he utilized. Similarly, you might have come across this term called tariff while your mobile phone recharges. How much cost do the mobile operator charge for you talking for 1 second or 2 seconds, 1 paise per 1 second. Similarly, that is called as a tariff, the rate of charge, okay, the price of rate of energy consumption. So that is the tariff actually. So the electricity bill usually has two parts, a fixed part and a variable part. So fixed part is that part of the bill or the cost to be paid by the consumer every month, irrespective of his energy consumption. Though he consumes or does not consume, that fixed part has to be paid by the consumer. This system exists because the utility spends a lot of cost in making the consumer to be connected to the power line always. So it includes some capital cost. Even though he is consuming or does not consume, the power line must be connected to his premises, and which is to be maintained by the utility company. Therefore, a fixed charge has to be made. So that usually we call as base charges. So, in the example given here, let us assume base monthly charge. Base monthly charge is rupees 12. Okay, rupees 12 per month, the base charge or the fixed charge, irrespective of the energy consumed or not. It is to be made every month, definitely. So regarding the tariff, now we come into the original tariff, that is according to the how much energy consumed. So first 100 units per month. Okay, first 100 units per month will be charged at the rate of rupees 0.16, that is 160 paise. Okay, that is 16 paise, that is 16 paise. Say for next, okay, for the next 200 kilowatt hours or 200 units per month in the same month, let us say the charge of energy is 10 paise. So 0.1 rupees. Again, anything above 300 units per month. Say it is charged around rupees 6 paise, 0.06 rupees. So this is the tariff rate of that particular power utility, and they charge per month in this manner. So as you see the tariff flow, as the energy consumption of the consumer is increasing, the tariff, the rate of the energy, the power, the cost of energy is reducing. During the first 100 units per month, he was charged at 16 paise, whereas after he crossed this block of 100 units, from 101 to 200 units, his price of energy was as 10 paisa. And over 300 units, he was charged for 6 paisa per unit of energy. Okay. So you see, as the energy consumption is increasing, the rate of energy is reducing. So however, this is the case in olden days when the electricity market or the electrical technology was in rise, or in the early period, because during time when the electrical grid was established and all the power system is just penetrating into the world, there was surplus of generation and deficit of consumption, because not all parts of the country are having the connectivity to the power grid or the power lines. Hence, the connected load is less, but the power generation was high. Hence, to maintain good load factor for the power plant, it was decided that to encourage the consumer, this kind of a fashion of encouraging to consume more energy by reducing cost as he increases the power consumption or the energy consumption was made. But however, this is not the case of tariff these days. These days, as you go on increasing your energy consumption, your cost per energy will be increasing definitely, because now we are having a deficit of power generation and there is excess of demand. So we need to utilize our scarce energy resources. So the government is making this kind of provision of increasing the cost per energy as the units consumed will be increasing. So that is the case today. So however, we will work out this problem. So for that, in the month of January, okay, in January, his cost of energy would be, so in January, he has to make this rupees 12, definitely, whatever may be the reason, though he consumes or does not consume. Now coming to the first 100 units of the month, he was charged at 0.16. So say 100 units, 0.16 rupees per unit. And during the next 200 units, he was charged at 10 paisa, that's 0.1 rupees. So during the next 200 units, 200 into 0.1 is the cost of next 200 units. And above 300 units, means after consuming 300 units, so here we have taken into account first 100 units, next 200 units, totally 300 units of energy has been calculated. Now what is the remaining? Now whatever above the 300 units, now above 300 units if we talk, here the total energy consumed was given as 700 kilowatts hour. So 700 minus 300 which we have already calculated. So the balance is 400 units. So now we have to make the cost for 400 units. So 400 units into cost is 0.06. So if you work out this will give the total bill. So this is rupees 12 as it is, and this would be rupees 16, and this would be 20 rupees, and this is 24. So add them up, you get rupees 72 for the month of January. So this is his energy bill for the month of January. So this is how the power utility utilizes the concept of energy in order to make a bill for you, energy bill for you.